Hello, it's Ernie, and I'm super excited to talk about Art API, a project that I've been working on to do automated annotation of artworks using artificial intelligence. And we're interested in colors and objects in particular, so that hopefully users will be able to search using this text, hence making paintings and artworks more accessible and more searchable. So I'll talk about the problem that we are hoping to solve for, the approach that I'm taking, the contributions that we're hoping to make, as well as where we're at right now in terms of development. So let's go straight into things. So essentially, the problem that we're trying to solve for is the fact that a lot of art can be very inaccessible because of the lack of metadata. If you look for bananas in Google Images, you'll easily find lots of images that are bananas, but try doing that on some collections engines and you'll find that unless it's already present somewhere in the data, right, you won't be able to find it using such intuitive terms, which makes it really hard for people who do not really know the art to, simply find things that they might be interested to look at. And of course, it's a challenge for art historians as well, because often the times if you're trying to study how a certain thing is depicted over time, you'll probably have to literally do that manually, maybe even walk the galleries or something. But of course, the whole idea is that AI should be able to help us do this a lot more efficiently and effectively. And at the end of the day, we do not want to do this tagging manually because that could involve lots and lots of effort, right? And I think the kind of like the overarching problem behind all this is really what people call the cross-depiction problem in literature. That is, how do you tell that a banana is a banana no matter how it varies in style and visual depiction, whether it's in a cartoon or in an artwork or in a photograph? This is something that's super easy for humans to do, right? But super tough for machines to crack at the moment. So what we're trying to do here in terms of object detection is actually sort of pointing somewhat towards that direction as well. So that's the problem that we are, so those are some of the problems that we're trying to deal with effectively. And the approach that we are taking is really, again, it's a bit of a double whammy and a vicious cycle in which, because there is no data available, the AI cannot be trained. And because the AI will be trained, this will never get done by humans alone. So what we're really doing here is actually to automate the annotation of these artworks, and we're looking at colors and objects in particular, right? But the problem, when it comes to the actual implementation, is that such annotations are very few, are extremely sparse, compared to annotations for natural photographs. So anyway, the approach then is really to use OpenCV for color extraction, which is actually fairly straightforward. And then as for the object detection side of things, I have managed to find some existing datasets that I'll be using, and the whole idea is really to run through various possible CNN architectures or convolutional neural network architectures, a very basic one to use as my baseline, and then VGG residual networks, and actually to perform some transfer learning from a lot of these existing models as well. So that is the approach that we are taking essentially. And I guess the contributions that we are hoping to make is really to inspire more people to be more interested in applying AI to other domains that you may have never thought of before, whether it's art or accounting or whatever. And we hope that this will make the corpus, the collections in Asia, in our part of the world, more visible, right? And actually encourage more public participation, because at some point it'll be super useful to have a lot of people looking at these artworks to verify the text generated by AI. And we also hope to build a case for open access to the arts, whether it's by looking at collections as a form of API, or maybe even institutionalizing some form of data spaces in which different galleries, museums from not only in one country but from around the region and around the world can actually share their data and their practices. So those are the things that we hope this project will be able to make a little contribution towards. And now I'll go straight into the notebook to talk about what we have managed to find so far in terms of our findings to date. So I've finally managed to clean this up, and this is the baseline model that I've built for object detection. I think so far our work on object on color extraction has also been proceeding pretty smoothly. The challenge, a lot of the challenges that you usually encounter when it comes to these things is really just finding the data to deal with, thinking about ways to optimize these models with limited computing resources, and then of course often the times there's also a bit of back to basics when things throw up random errors and you have no idea what's going on. Then as you kind of like trace things back and so on and so forth, you realize it's really because you've made a super silly mistake. But anyway, so we have managed to do some object detection, and the accuracy is not something to be proud of, but I think it's exciting that at least it's been proven that this thing could be done, right? Though again, like, many other people have done it already, but I think it's really about putting your own stamp on things and to apply it to a problem, a domain of a particular interest to yourself, and then to figure out ways to actually improve this further with more data, with different architectures and so on and so forth. But anyway, so the basic workflow of what we're trying to do here is actually to just load and use images that we'll be using for training. So luckily, I was able to find this this whole kind of like database of about 8,000 over works that's been made available by some British researchers on the British National Collection. So it does come with annotated text for about 10 object categories already. So that's a wonderful starting point. But as with all things, you still have to treat the data before you do any work on it. So we've basically dropped duplicates and dropped anything that's missing. And really, this part here is just trying to extract the file names and download the images, because what happens with a lot of these images online is that they could also, the URL could also no longer be working, right? So you want to make sure that you're only working with images that you can use and access, which again is so important when it comes to dealing with data and AI. And I really hope that more people can put more efforts into making all these things a lot more accessible for people, because it's kind of like the models and the algorithms are all so easily accessible. All you have to do is just import all these things that so many countless strangers have spent so much time developing and making it easy for people to access. But often the times it's the data that's really tripping people up. Oh, but anyway, let's go back to the notebook. So after all these things have been loaded, right, next thing we want to do is to actually extract all the different categories that are inside. Or what people like to call class labels and whatever, but essentially these are really object categories of interest. So that's what we're trying to do here by looking at this particular labels column and extracting the individual words inside, and then kind of like really just doing some encoding so that you end up with something like this, where it will just tell you, okay, there's a cow in this image, and then there's a train in that image, and so on and so forth. And I'm also saving my data frame and all these results so that subsequently we can reuse this easily and use it in production without having to run through all these things, all over again. And now that all these things have been prepared, we can start to prepare our images for training. So typically you want to resize your images, maybe even rescale them a bit so that... oh, actually I didn't rescale them here. Oh wait, actually it's done here. Oh yeah, anyway, so you want to resize and rescale them, do some basic treatment, and then later on we can also do a bit more thoughtful, a lot extensive treatment, in terms of like rotating the images, flipping them, augmenting the data, and so on and so forth. But at this stage where I'm just trying to build a baseline model, we will just resize it and then, pass in our X and our Y. So Y is kind of like the targets, what you're trying to predict, and X is the features that you are feeding to AI to tell it to, find some patterns to then essentially find how X kind of like maps into Y to give us that prediction, right? So it's super important to do all those things that we're doing previously and to arrive at the point where both your X and Y aligns, in the sense that the shape of your data, right, is of the right and matching shape to work with. So if you have 8,296 paintings, you also have 8,296 target data for this set of paintings that you're working with. And we split them into data that we use for training, data that we use for testing, as well as data that we use for validation. So anyway, and then this is a super basic convolutional neural network that I built here. They just copy code from somewhere. Yeah, but anyway, these are some of the important things here, which is really that for the problem that we are solving for, which is what people call multi-label classification, right? Because it's not classification in the sense, it's not just one kind of classification in the sense that you're saying 1 or 0 to kind of like one thing, or one of those scenarios in which an object is really one of different possible categories. It can be more than one of all these different possible categories. In a painting, you could have a banana, an apple, and so on and so forth, right? So it's a multi-label problem. So for multi-label classification problems, usually you want to use your sigmoid activation for your last layer and the 10 classes that you're dealing with, or whichever number of classes you might be dealing with in your final layer. So I pretty much compiled this model based on some of the recommendations that are found online. And here's the model summary. So you can see that even this very simple baseline model has about 190,000 parameters to be trained. So thank God for GPUs. Except that I had this sudden issue with GPUs as in getting this GPU to work. But anyway, there's something else that I need to troubleshoot later. The good news is you can run this on Google Colab. Yeah, so anyway, then we've established some early stopping criteria, and then really start to train and fit the model, as you can see here. So because my GPU is not accessible by my, I think it's this WSL2 thing for some reason, limited only to 10 epochs of training. And you can see that at the end, we have an accuracy of about 38%, which is not too bad, considering the fact that we only train this for 10 epochs, and my data set is actually also really small, right? But there are also some caveats when it comes to looking at this particular performance for multi-label classification problems, in the sense that, if I'm not wrong, I think this is saying that this 38% applies to the fact that it's able to predict one of the multiple possible labels in one painting correctly, right? I mean, I have to check that out, but I think that's kind of what it's talking about. But anyway, these are just some metrics for how our model is performing over time. I won't go too much into it now, but I think this is the super exciting part. Right, so after we save our model, we can actually use it to start predicting on some test data that we split from the data set that we're working with. So as you can see here, right, I mean, I'm just trying to display the first 10, a set of 10 images for kind of like sense checking to see what's going on. And of course, there are many other things you can do to the code and these models as well to look at what's going on under the hood. But I think for this moment, and kind of like based on what I've been seeing so far, the interesting thing for me is really that this model so far seems to be really good at picking up bolts. Yeah, like, and I suspect that has to do with the fact that perhaps bolts have been rendered or painted, typically in settings that are quite distinct from other sort of paintings, right? Because when you think about boats, it usually appears in the middle of an ocean, and the ocean is usually blue or maybe looking somewhat green or whatever. So that kind of like tells you something about the way that boats have been painted over time, and perhaps even our relative lack of creativity, when it comes to how we depict boats. Trains have, this particular train, right, has also been identified as has also been predicted very strongly. But anyway, I think this is a high level, overview of what the AI has been capable of, just based on a very limited set of training data, a very simple model. And the next steps are really to start to add in more features, pull in more data, maybe even generate some data that will be useful for our training purposes. Of course, to also look at other more complex architectures and do some transfer learning. And last but not least, turn this whole thing into an API and a working product that could be deployed into the cloud as well. And all this to be done by 2nd October, so stay tuned.